Welcome to LearnC. Today we will be discussing fundamental concepts of algebra, and by the end of this video you will be able to define constants and variables in your own words, differentiate between constants and variables in a given algebraic expression, identify literal and numerical coefficients, identify monomial, binomial and trinomial, and identify like and unlike terms. Observe this pattern formed by two line segments. Can you tell me how many line segments are required to form 6 L's? Try to fill the table. Yes, 12 line segments are required to form 6 L's. 14 line segments are required to form 7 L's. How did you get this? Yes, that's right. Number of line segments required is twice the number of L's formed. Let us write letter N for the number of L's. Then the above statement can be written as number of line segments required is 2 multiplied by N or 2n. Note that 2 multiplied by n is same as 2n. Thus, for n is equal to 1, number of line segments required is 2 multiplied by 1, which is equal to 2. Similarly, for n is equal to 2, number of line segments required is 2 multiplied by 2, that is 4. For n is equal to 3, number of line segments required is 2 multiplied by 3, that is 6, and so on. Here n can take any natural number 1, 2, 3, 4, etc. These numbers agree with those from the above table. Using this rule, we can say how many line segments are required to form even 100 L's. We do not need to draw the pattern or make a table once the rule is known. From the above expression, it is clear that the value of n is not fixed. It can take any value. So we call n as a variable. Whereas the number 2 remains the same always. So 2 is a constant. Its value is fixed. We use English alphabets X, Y, Z, A, B, C, P, Q, etc. to denote variables. Now, can you identify the variables and constants from the given expressions? Excellent. Now, consider the algebraic expression 3x plus 4y equal to 8. Here, you can see a constant along with the variable 3 and 4. They are coefficient of x and y respectively. Now let us define coefficient. Any factor or group of factors of a product is known as the coefficient of the remaining factors. I repeat, any factor or group of factors of a product is known as the coefficient of the remaining factors. Consider the algebraic expression 8ax. In this, 8 is the coefficient of ax. 8a is the coefficient of x. 8x is the coefficient of a. And ax is the coefficient of 8. Here, a and x are called literal coefficients, whereas 8 is called the numerical coefficient. Now it is your turn. Identify literal and numerical coefficient of 20xy square. That's great. Now, look at this algebraic expression 10 plus 3x square minus x. Here 10, 3x square and x are connected by the operation signs plus and minus, and hence they are called terms of this algebraic expression. The part of an algebraic expression connected by the operation signs plus or minus are called terms of that expression. In the above expression, there are three terms: 10, 3x square and minus x. In 2y plus 3, 2y is a term and 3 is the other term. Now it is your turn. Identify the terms in the following expressions. Now, go back to the expression 8x square minus 3xy. As you know, it has two terms, 8x square and minus 3xy. The first term, 8x square, is a product of 8, x and x. So, 8, x and x are called the factors of 8x square. Minus 3xy is a product of minus 3, x and y. So, they are the factors of minus 3xy. Have a look at these following algebraic expressions. What did you notice? In the first expression, there is only one term. In the second expression, there are two terms. And in the third expression, there are three terms. Expressions that contain only one term are called monomials. Expressions that contain two terms are called binomials. And expressions that contain three terms are called trinomials. But in general, all these are called polynomials. An expression containing one or more terms with non-zero coefficients is called a polynomial. Now there is a small exercise for you. Identify monomial, binomial and trinomial from the following set of expressions. Now look at these two set of expressions. In the first set of expression, all are having the same literal coefficients. So they are called like terms. But in the second set of expressions, they do not have the same literal coefficients. So they are called unlike terms. Well, that's all for today. We will be discussing more on this topic in the next video. Hope you have understood all the concepts discussed. We will discuss more on this topic in the next video. Stay safe and take care.